Okay, this video is my second example, so I'll kind of jump into it more quickly, but this is problem 53 from chapter 11, the OpenStax Chemistry textbook, second edition. And so what we got here is a molar mass problem, okay? We want to know the molar mass, and we have some different quantities here, okay? So first, what we need to do is find some information. So we've got 12 grams. Okay, so that's a good quantity. We have 80 grams of water. We'll have to convert that to kilograms later. And we have the solution freezing point. Now this is water, so let's get some information here about water. The freezing point for pure water is 0 degrees Celsius. And the Kf for water is equal to 1.86 degrees Celsius per molality. That can be found in the table in the textbook or my appendix if you're taking my class. So let's go ahead and do the calculations. So first, what we want to do is use this formula here. And what we want to do is find the change in the freezing point, not the actual freezing point. And so the formula we use is the temperature of freezing of the solution is equal to the pure freezing point of the pure minus the change in the temperature of the freezing point. So this is the basic formula we use. Now, here we know the solution freezes at negative 1.94. Pure water freezes at 0, and we want to solve for the change, okay? And so the change is equal to a positive 1.94 degrees Celsius. Okay, the math there is relatively simple. Now, what we want to do is next find the molality. Okay, find the concentration. Okay. So normally the change in the temperature of the freezing point is calculated by plugging in the things on the right side of this chemical equation, but we actually know what the answer is. It's 1.94, right? And that's going to be equal to the constant here that I looked up, okay, times the molality. So that's what we're trying to find out, okay? And I'll just do this on my calculator. 1.94 divided by 1.86 is equal to 1.04 molal, okay? So that right there is the concentration, okay? Now, let's go ahead and calculate the kilograms of the solvent. Okay, it's important to know it's the solvent, right? So the solvent is a substance in more amount, and here we know it's the liquid water, right? So we have 80 grams. And basically you need to, you need to move the decimal place over 3 places. Okay, and I'll write, solvent here so we can remember that that's what I'm doing. All right. Now we know molality, we know solvent, the kilograms, so we just want to find moles. So the next thing we want to do is find moles. Okay. Now here's the formula we're going to be using. Okay. The molality is 1.04. We've calculated that before. And the moles we don't know. Okay. And the kilograms we do. It's 0.0800. Okay. So the number of moles we have here, 1.04 times 0.0800 is equal to 0.0832. Okay. So basically in this formula here, we know the molality, we know the kilograms, and we're just finding the moles. Now, our next step here is to use the molar mass formula, right? Molar mass is mass over moles, right? Is grams per moles. Those are the units. The grams that we have here from the word problem is 12.0 grams, okay? And the moles we've calculated prior to this. Okay, and so you literally just find that fraction, 12 divided by 0.0832, and I get 144 grams per mole. Okay. So in summary, in step 1, I found the change in freezing point. Step 2 is to find the molality. Step 3 is to find the kilograms of solvent, okay, using the word problem. Step 4 is to find the moles. Step 5 is to find the molar mass. Grams, once again, is from the word problem, and moles is from that prior calculation. And we basically get the answer. Okay, so you find the molar mass using that formula. Thanks for watching, and if you like these videos, subscribe so you can see more content.